Yeah, so on our today's lesson, welcome for the three-dimensional geometry. This is in for topic 3D, the topic 3D, and the question is already provided here. The question is already provided for you. Now, the figure below shows a right pyramid with a rectangular base. Rectangular base, A, B, C, D. It's a pyramid where these all the slant edges meet at point T, and this is the vertex. So you are told that TC equals to TB, which is equals to TA, and TD equals to that. Therefore, and they are equals to 17. Then the vertical height TO, the vertical height of this pyramid TO is 15. Now, then you have given further that AB is twice BC. AB is twice BC. AB is twice BC. So question number one on this three dimension. Calculate the length of BC. Calculate the length of BC. So that's where we are going to start in this question. Now, because you are told that AB is twice BC, let BC BX. So let this one BX. That is BX. That is BX. That is BX. Therefore, BC must be 2x. BC must be 2x. So therefore, find the length of BC, or find the value of x in this case. Now, when you are given this perpendicular height, this vertical height, the vertical height is perpendicular to AC, diagonal AC at point O. So this angle is 90 degrees. Therefore, this forms a right angled triangle that looks like this. You have T, O, and C. So we need to know to get OC, so that once you get OC, we also get OA. OA is equal to OC. The point of intersection bisect this diagonal here to the center here. So therefore, find this at an angle of 90 degrees. TOC is 90. And this is 17. And TO is 15. Can you find OC? Find OC. To find the length of OC, using Pythagoras theorem, you say OC squared would be equal to 17 squared minus 15 squared. So 17 squared, that is 289 minus 225. Minus 225, you get is 64. So OC squared is equal to 64. So OC is equal to the square root of 64, which is equal to 8. Therefore, the length of OC, O to C, is 8. The length of OC is equal to 8. So therefore, what is the diagonal? The length of the diagonal is from A to C, because this is 8, also this is 8. So our AC is equals to 8 times 2. We get that is 16. We get that is 16. So therefore, the length of the diagonal AC is 16 centimeters. Now, because this one is a rectangle, the base is a rectangle, ABC, there must be a right angle. The angle is 90 degrees. So you take this triangle ABC as right angle. It is a right angle triangle. So you express AC in terms of, using the Pythagoras theorems, in terms of x, in terms of x, or in terms of x squared. So get the sum of, so get AC squared. AC squared is equal to AB squared plus BC squared. So that's how to find this one, to find AC. And we have got that our AC is 16. AC is 16. So therefore this one will be 16 squared is equal to 2x bracket squared plus x squared plus x squared there. Go this side, this is a right angle triangle. So this angle here is 90 degrees. So 2 squared, 2x squared plus x squared. So you put this bracket here, you get 256 is equal to 4x squared plus x squared plus x squared. So therefore this is, you square everything. 2 squared for x squared. So get 4x squared plus x squared. So this becomes 256 is equals to 5x squared. So for you to get x squared, because we want the value of x here, divide by 5 divided by 5. So 256 divided by 5. You get this is our x squared is equal to 51.2. 51.2. That is x squared. So our x squared is 51.2. So find x. Our x will be equal to the square root of 51.2. Square root of 51.2. You get that x is equal to 7.155. We give our answer to four significant figures. So therefore the value of x is 7.155 centimeters. So that's how you get the value of x. And in our question, we were looking for BC. So therefore the length of BC is this one, 7.155 centimeters. 7.155 centimeters. Let's deal with it in four significant figures. So that is the length of BC. Then the second question. The second question there is the angle between TC and the plane ABCD. Therefore, you are required to find the angle between a line and a plane. The angle between a line and a plane. So the angle between a line and a plane, this line TC and plane ABCD. So the first step it is to identify the projection of this line or the shadow of this line TC on the plane ABCD. The projection itself. The projection. So let's see how do you find this one. So let's first of all identify the projection of this line. So let's identify that. 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 So therefore, our BC, note that our BC, this is 7.155. So therefore, our AB, what will be the length of AB? We can even note that one first. Our AB will be 7.155 times 2. You multiply that times 2. You get 7.155 times 2. You get this is AB is 14.31 centimeters. So therefore, the length of BC of AB, this will be 14.31 centimeters. 14.31 centimeters. So therefore, let's find the angle. The angle between TC and plane ABCD. So identify the projection. The projection in this case, it is the shadow that this line makes on the plane. So this one, the projection, this one, if this is TC and this plane ABCD, this TO makes an angle of 90 degrees with the center of the, or with the point of intersection, or with the perpendicular height, the vertical height, makes an angle of 90 degrees with the what? With OC, or with the line OC. So therefore, the projection of TC will cast the shadow along on this plane is CO or OC. So this will be the projection. Our projection will be OC. So projection there, projection is OC. That's a projection. So when you want to calculate the area between a line, the angle between the line and a plane is the angle between a line and it is projection on the plane. So therefore, because we have identified our projection is OC, then this one, you draw this right angle triangle here from T, O, and C. So this angle is 90 degrees, and this is 17. Then the height of this one, we were given as 15 centimeters. TO was 15 centimeters, and the other one is the slant edges is 17. So find angle, the required angle between TC and plane ABCD is the angle between the line and its projection. So the angle required is TOC. TOC. Call this angle theta. Call it angle theta there in this case. It is angle theta. Lights are here. The three trigonometric ratios. So that you know which trigonometric ratio do you need to use? Which trigonometric ratio do you need to use? So we don't have adjacent. We don't have, in this case, we can use, we have this one, we got this one, but we can use what you have. Hypotenuse and opposite. Hypotenuse and opposite. So you can use this one because you require this angle. That's the required angle. So you say opposite hypotenuse. You can leave the adjacent side. So you say sine theta, in this case, is equal to opposite, which is 15 over 17. 15 divided by 17. You get this is 0.8824. 0.8824. So therefore, to find the angle, you find sine inverse. The sine inverse of this one. Sine inverse of this of 0.8824. So using your calculator to find the angle theta, you press shift sine, gets an inverse of 0.8824. And the angle in this case is, the angle theta required is 61.93 degrees. It is 61.93 degrees. That is the angle between a line and a plane. So it is the angle between the line and its projection on the plane. So the angle that we needed was 61.93. There is 61.93. So that's how to get it. So the angle between the line and its and a plane. It's the angle between the line and its projection on the plane. The last question here is the angle between TD, line TD. You can see the line TD and the project and the plane TAC. TD and plane TAC. Now you have this TD. On this plane TAC, where does this point T make an angle of 90 degrees? With the plane TAC. So that you can identify the projection. That's why we need to know where it makes an angle of 90 degrees along that AC, so that we identify the projection of that line. So therefore, let's see. So we can love this. We can love this one. Now, so we can have this now. TD and plane TAC. The projection of TD along plane TAC is TO, where this line makes an angle of 90 degrees. This is the perpendicular height. That's the perpendicular height. So you can see that's the perpendicular height. So the required angle between TD and plane TAC is angle is DTO. Required angle for Roman 3. The required angle is angle DTO. That's the required angle. The angle between the line and its projection on the plane is the angle between the line and the plane. It's the angle between the line and the plane. So therefore, the projection of TD is TO. Projection of TD on plane TAC, on plane TAC is TO, is plane TO. So therefore, on plane TAC, the projection is TO. So the required angle is DTO. So how do you get that? How do you get that? So let's see. How to get that one? You have this makes an angle of 90 degrees there. You can draw this. It makes an angle of 90 degrees here. You have T, you have D, and you have O. So the required angle is this one. This is the required angle. That's the required angle here. We can call it angle beta, because the other one was theta. We call this one beta. So what is DT? This was 17. What is TO? TO was 15. That was 15. So therefore, this angle is 90 degrees. Again, light socket tower here. Light socket tower. Light socket tower. We don't use the opposite. We just use adjacent. If this is the angle beta, this opposite, adjacent, and this hypotenuse. So leave opposite, sine and tan. Leave that one. So use cos because you have adjacent and hypotenuse. So you say cos beta is equal to adjacent 15 all over 17. So 15 divided by 17. In this case, you get cos beta is equal to 0.8823. 0.8823. 0.8823 in this case. So therefore, to get the angle DTO will be cos inverse of 0.8823. You get that one. So shift cos 0.88 to, in fact, it is 24. It is 24. 24, not 23. 24 there. 0.8824. And the required angle here, our angle beta is 28.067 degrees. So I've got DTO is equals to 28.07 degrees. Writing the angle in 4 significant figures. So that's how you are supposed to solve that kind of question. And there's a 10 marks question on 3D, on 3 dimension. So therefore, you must understand that concept. The concept of the angle between a line and a plane. The angle between a line and a plane. It is the angle between a line and its projection on the plane. And in this case, the projection is the shadow. The shadow where this line, if it, for example, is TC, makes on the plane ABCD, the shadow will be CO. And therefore, where the line makes the shadow, the angle must make, you must get a right angle triangle on this one. So therefore, this one will cast the shadow here. TC will cast its shadow here on this plane. So therefore, the angle between TC and plane ABCD is angle TCO, because CO is a projection. Is a projection. So the other one we have said that the angle between this TD and plane TAC. TD and plane TAC. Identify where this line AC there. The point T, where it makes an angle of 90 degrees on this plane. The plane itself, it is this one. It is on point O. It is point O. So therefore, this line TD casts the shadow on TO. So the shadow of TD is TO. Therefore, the required angle between TD and plane TAC is angle DTO. And that's the angle that you have calculated. Because now there is 17 and this is 15. It is this one here. You require this angle DTO. Use this one. This angle better. And this is 17 degree. Then you have 15 this side. And then you can leave this one. We can leave this opposite side. We just use this one. And therefore, when you write socket tower here, the 3 trigonometric ratios, you choose which one to use. And in this case, because we don't have hypotenuse, we use cosine. You say cosine B is equal to adjacent 15 over 17. You get 0.8824. Then from there to get the angle better there, you say cos inverse. So using your calculator here, just press shift cos. You get 0.8824. And you get your correct answer is 28.07. And you can also use the math table to check the cos inverse, the angle from the mathematics table. You can use that one. So thank you very much for that lesson. I believe you have enjoyed the lesson. So asanteni sana.